Hi, everyone. We're going to take a minute and we're going to talk about assemblies. We've got our machine vice up. This is taken right out of the textbook or one of the textbooks we use. And it's actually chapter 14, problem 51, I think, in the book, figure 51 in the book. So here's the base of it. We've already got it laid out. We've made some minor changes just because Inventor really doesn't do like Acme threads well, and I'm not going to teach you that right now. We'll do it later. So we've put Unified National Course threads on, following the same normal guidelines. We've made a couple of minor modifications like that just to make things a little easier for our students. But basically, I've got all the parts laid out here. I've got the collar, and when I do this stuff, if it tells me what the material is, like this base, it doesn't tell me what exactly what it is. I'm assuming it's a cast steel, but I'd have to go do some looking to figure it out. Some of this stuff is like a normal SAE 1020, which is a mild steel. So we'll look through it, and then we'll just add up the ones and associate them roughly for right now until we get into materials with a close approximation of what's going on here. So here's our home page. I'm going to start with our assembly right here. And I'm going to look at the accelerators in here. Design accelerators are great tools if you use them. So we're going to take a few minutes and look at one of those. But first, I have to start an assembly, and I have to save the assembly. So I'm going to open this up, and I'm going to come down here to my CAD 3. I'm going to find that folder I've been working in, which is our machine vice right there. So I'll open it up. And I'm going to drop in the base piece right here. And I'm just going to drop it in space and go right-click. And immediately after I've set that part, pardon me, I'm going to right-click on it over here in the menu, over here in the design tree, and I'm going to ground that part. That is my base, so that's definitely got to be the one that's grounded. Everything else is based off it. It moves around it. Everything attaches to it. So once I drop it in, I can drop in the other parts. Now, I'm going to drop in the movable plate right off the bat. So I'm going to, not the jaw, I'm going to pop in the sliding jaw right here. And I've got to put in some other parts, but I'm just going to eyeball in where he goes. And I'm going to constrain him roughly. I know that as far as parallelity goes, that surface and that surface right there have to be parallel to each other. Okay? And if I tip him up, so I can tell what's going on here, got to tip him up a little further, Benson. I'm going to tell it that this surface here and this surface below it, right here, should be touching each other. Apply. Now, I can move this forward and back, but it stays in line there. Okay? Now, we're just going to leave that right there for right now. It doesn't really matter where it's sitting for a moment. Next thing, I will put in the collar. So there's a collar that screws into this, and I'm just going to place it roughly, kind of associate in the right spot. It comes in, it's like 90 degrees out of whack, so I'm going to actually go in here and rotate it on my y-axis until I get it roughly correct. Now, from the example I've got here in the book, I'm not sure which way this orients. I'm just doing my best guess right now. So it's going to orient that way for what we're doing right now. And then I'm going to come over here to my constraints, and it's a concentric constraint. I'm going to constrain this to this. And I'm going to flip it around so it sits right snug in there, fits all the way in the collar. Now, the next thing is I need the shaft that threads into that, the shaft that is actually the screw shaft that drives the vise. So right now I'm looking at going, well, where does it go? Well, it's going to travel through here, but it's going to be constrained to this. So as this turns, it's going to move this forward and back. Okay? So I'm looking at it going, okay, where does that got to fall? Well, let's figure it out. What's really going to happen is, and this is one of those weird things, this piece right here, this collar will thread in and fit around my shaft, and there is a special collar that fits over the shaft at the other end of it. And I haven't put it in yet, but we'll worry about that in a minute. So I'm going to simply take this guy, and I'm going to drop a shaft in there. So if I go like this, I can use the design accelerator right here. But I have to save first. I'm going to save this assembly. And I've already got one here. I'm going to call this in version B. So I'll just type this. And we'll go down here and go version 2. Okay. And drop this shaft in here. Now I can use the accelerator. So if I use the shaft tool right here, the shaft comes in and it gives me this big old shaft right there. Well, that's not the shaft I need. That's not the shaft I want. So I'm just going to drop it for right now and let it sit for a second and then start making some modifications over here. First modification I got to make is I'm looking at this thing. Well, the first piece of it is a 1/2 inch in diameter and is a grand total of 1/4 inch long. So he's little. The next piece of it here is also a cylinder, but it is 0.375. This is where that special shaft goes around. And it is between 0.131 and 0.128 in length. And I'm taking the maximum out, so it's kind of sloppy. Okay. Now, this cone doesn't exist in ours. So I'm actually going to hit the delete button right there. Yeah, I know, we're going to get rid of it. This next piece of shaft right here, I'm going to edit it out. It is, again, 0.5 in diameter. And when I did the math, because this is where the slop's taken out in our design, this comes out to 1 inch, and if you actually do the math, it's 1 1,000th of an inch. So just to get it dead on right with the numbers I have. It wouldn't really be that in real life. It'd be 1 inch or whatever, but that'll get me there. Now, I don't have enough shaft here. I'm like sections short. So I'm going to add a piece of shaft right here, and this is just insert a cylinder. I can also insert split sections and conical sections and polygon sections, but I'm going to just insert a cylinder. This cylinder right here, we're going to open him up. He is actually 0.625 in diameter, and he is 3.937 long. Okay. I go, okay, right here. Yep, that's fine. Oh, cancel this. I tried to close out the design section before I was done. I'm going to add another piece that goes back to wherever the last one was. This one actually is 0.5 in diameter, and this one is, again, 0.25 long. So this is the relief. This is the threaded portion. I'll put the threads on in a minute. Okay, right there. And then I got to add where the crossbar goes. So I'm going to put in another cylinder piece. It is 0.75 in diameter, and it is 0.812 long. And that's my whole shaft right there. Now, I'm looking at this. I don't have anything on this end, so it's got no feature there. Should have no feature here. Should have no feature here right now. Whoops, cancel that. No feature there. So everything's just square corners for right now. I'm trying to keep it simple. Now, on this portion right here, I should have it threaded. So I'm going to right click on this first piece, add some threads. Well, it kind of defaults the UNC course. That's what we'll leave it with for right now. I can get into specifying the threads if I need to, but for what we're doing with this stuff with our kids right now, no, I'm just going to leave it as a UNC, a 5/8 by 11. Put that in. And now, one thing I didn't do, it's not threading the whole shaft. That whole portion of shaft, that is 3.937 long. I need to thread the entire length of it. And down here on this piece, I'm going to add a hole through it for the T-bar to go through. So that hole diameter right here, diameter hole, is actually 0.3438. I'm just going to punch the hole right through. You can see it setting up right there. Once I do that, I can go right here and go, okay, and drop it in my drawing angle place. There he is. Now, it automatically generates in my design tree, in my file folders, this part. It literally makes a part of it and puts it in there for me. So I don't have to worry about that part. Now, here's the fun part. This set screw right here is actually so I can unthread that thing. But this piece is where that collar goes around that's on the other end of this collar. So I've got a special key that goes across that, and then we thread this in. It's kind of wonky. You have to use the right tools. So that has to line up with this, but be offset the 0.812. So what I can do is this. When I go back in here to my assembly, and I constrain concentrically this to this edge, I want to make sure it's the edge of the actual part here. That puts it flush with it. If I tell it to be minus 0.812, it sets it in there so the other end of it is on the other end of that shaft. So once I apply that, we're in good shape. Now, I can pull this forward and back, okay? And I should have, honestly, I should have made a sub-assembly of this and then inserted that into this piece right here. But that's for another time. You can do sub-assemblies and insert those assemblies in. So that's how we assemble a part. That's how we make a shaft. Good luck, have fun, and we'll keep going with this, and you'll see some more videos of it. Thanks, bye.